Well, hello, CAT aspirants. Welcome to this new series where we will pick up a topic that will help you to concretize the basics and form the fundamentals of quantitative aptitude, and that is equations. But we'll not just learn how to solve an equation, we'll also learn how to optimize variables. And we'll also go ahead and look at the modern game of CAT. By the modern game of CAT, I mean the last 2 years where it has tested the aspirants on how to visualize or observe within the equations. So my name is Rahul Bathla. I'm a CAT 99.95 and a Quant 99.98 percentiler. Let me walk you through this modern game of CAT and let me make your basics as firm as they can get you to 99 percentile. By the end of this session, you will also be able to solve a question like this, which eventually is a CAT 2025 slot 2 question. And not an easy one or a basic one. This is a good question based on observation, aptitude, and not just mathematics. So the idea in this particular lecture is to get hold of what CAT actually is. Is it just mathematics, or is it just equation solving, or there is something extra which we might be missing? Let's start. So guys, in this lecture, we'll talk about first of all solving the equations, then the observation game, and then by the end we'll see how one equation with two variables can be solved if there is certain extra information given to us. I hope you'll watch the video till the end and let me know in the comments that how did you like the session. If yes, I'll continue with that such kind of series, right? And of course, I'm going to give you some homework questions as well. So first thing first, the basics, right? So what happens when we have a system or a pair of linear equations with two variables? I hope majority of you know it, but still, I'll just go with the basics, right? The people who know it can just skip by for the 2 minutes and start solving the questions. But rest, for those, this is very new, you can watch it. So guys, what happens is, let us say we have two equations and we have two variables x and y. Our main aim is to find out the value of x and the value of y. So there are two methods, substitution and elimination. Let's understand substitution. As the word substitution imply, we are going to substitute, but what? See, if I pick up this equation, this y will go here and becomes positive. 11 will come to the left hand side and become negative. I hope you know this basic. A variable or a term when goes from one side to the other changes the sign. So minus becomes plus, plus becomes minus. And that's it. Now what we have is y in the form of x. So what we have done? We have written y in terms of x. Now we can substitute y over here in terms of x. So now the substitution occurs. That is why this is called as substitution method. So we have 3x as it is plus 4. Now not y. Y is 4x minus 11. So the y gets substituted. So here the substitution takes place, and that is why this method is called substitution method. And now this of course is equals to 13. Now there is a single equation with a single variable. You can go ahead and find out x. Simple. Write down one variable in term of the other. Substitute that variable in the other equation. Okay. So I used this to find out y in form of x, and then I used this to substitute. So now I have 3x, and this is 4 just 16x. 16 plus 3, that's a 19x. And then I have a minus 44 equals to 13. You can add one step if you want to open it. I have done it directly. 4 just 16. 16x, 3x, 19x. Start adapting these methods so that you can be little quick. So 19x comes out to be 57. And eventually x comes out to be 3. Great. Now we have one of our variable, that's x, which is 3. Now not difficult to find out y. Why? Because we already have y in terms of x. X is 3. If I put it over here, I know y is equals to 4 into x is 3, right? Minus 11. So 4 into 3, 12 minus 11, that's a 1. So I know y is equals to 1 and I am done. That's the substitution method for you. That's how you can solve any two equations with two variables within seconds. With the practice, you will be faster, right? So what we did is quite clear, writing y in terms of x, substituting y in the second equation, and getting the x. Once x was known, we put it back to the y and get the value of y. Now I'm going to do the same equation, same pair of linear equation, and I'll solve it by elimination. So you get the idea, right? How both of them can lead to the same answers. Perfect. Have a look at this one. 3x plus 4y 13, 4x minus y 11. But wait a minute, guys, this is a recording, so I would advise you can pause, get hold of this, and then only jump to the other one. Okay? So you have that liberty of the space bar key, utilize that. Now, 3x plus 4y 13, 4x minus y equals to 11. Elimination method. The idea is to eliminate a variable. How to eliminate a variable? Focus on the coefficients. Try to make one of the coefficients same for a particular variable. Now this x has 3, x has 4, y has a 4, y has a 1. So I can make this. So where is 1? See, if nothing is written, you can write it down as 1y. And now, how can I make this 1 as 4? It will be very easy to make 1 4. How? Simply multiply the equation by 4. And I can do that because 4 is getting multiplied to left hand side as well as right hand side. No problem in that. And in that case, 4 1ja will give me 4, which we already have here. So the coefficient of the y will become same. That was the idea. So we multiply by a certain thing so as to make the coefficients of a particular variable same, in this case y. Now see, what are the equations you have? You have 3x plus 4y is equals to 13. And then you have 4 4 just 16x minus 4y equals to 44. So now what? Yes, fine, we have the coefficient same, but what's next? The idea is, once the coefficients are same, they can be used to eliminate the variable. How come? Have a look. I see that we have opposite signs, but the terms are exactly same. So if I add them, they get cancelled. So if you get the opposite signs, you add. If you get the same signs, you subtract. In case this would have been a plus 4y, so we would have subtracted. 4y minus 4y would have got cancelled. Opposite sign, 4y minus 4y got cancelled. 13 plus 44 is 57. We are adding, right? On 16 plus 3 is 19x. Again, we have x equals to 3. So that's substitution. And you can see the magic happened. The answer is exactly same. But wait a minute. How to find out the y? Come on, guys. You have x equals to 3. Pause and think for a moment. How will you get the y? Yes, absolutely. You have two equations. Put x either in this or in this. Doesn't matter. I am putting in this. So 3 into 3. X is 3, right? Plus 4y is equals to 13. So this is a 9. 4y. 9 goes that side. 13 minus 9 is a 4. Eventually, y also turns out to be 1. Fantastic. X3, y1. So we have learned the substitution method and the elimination method. That means now we have not just one but two ways to solve a pair of linear equation. Pause, try, once comfortable, move ahead. Sorted? Alright, I'll just step aside so that you can take a picture or you can just solve, get comfortable, and now it's turn that we move ahead. Alright, let's go, guys. Here is a question for you. You're gonna try this one on your own and then I'll also solve it for you. Okay, but before I solve, it's your time to try it out. Make sure you try, right? Don't just skip by. Otherwise, no point of learning, right? Don't watch it as a movie, guys. You have to solve it, right? All right. Assuming you have tried it. And now my turn. So I'll go by elimination, I guess. See, I only go by substitution when one of the coefficients in a particular equation is 1. Easy to substitute. Here, y had a coefficient 1. Was very easy to write down y. Otherwise, it generally goes into the fraction, so I ignore. I go by the elimination then. Now the point is which one to match, which coefficient we should go ahead and match. I cannot multiply anything to 2 to make it 7, cannot multiply 3 anything to make it 4. So that means I'll have to give both the equations something. What's the simplest idea? See, the idea is pick up any variable. Let us say you want to eliminate x. Here x had 7, so multiply this equation by 7. Here x had 2, so multiply this equation by 2. That's it. Coefficient of x here, coefficient of 2 here, just interchange the coefficients and see the magic. You are done, guys. Automatically x will get vanished now. You have done whatever was required. Let's check. 2 7 is 14x, minus 2 4 is 8y, 2 13 is 26. 7 2 is 14x, boom, we have it. Minus 21y, 7 zeros are 0. That's it. Same coefficients, but this time with the same sign. What happens when you have the same sign? Subtraction. Now let's subtract. So 14 minus 14 gets cancelled. Minus 8 minus minus plus. So minus 8 plus 21y, that's a 13y. 26 minus 0, that's a 26. Congratulations, guys, you have the y as 2. I can put in y any equation. Let's say I'm putting it in this equation. Forget about the 7, just put it here. Simple, no? So 2x minus 3y, y is nothing but 2, equals to 0. So 2x comes out to be 6 and x comes out to be 3. And we are done. x3, y2, the basics are done. We can solve the equations now. Yes? So we've already learned how to eliminate when you had the opposite signs. Now you learned how to eliminate when you have the same sign, when the coefficients match easily, and when they require some efforts. We know everything. Congratulations. One step done. Step 2. Let's have a look at this question, guys. This is a special case, right? Now, seems tricky. Pause and try. Substitution seems out of the picture. Elimination requires a lot of efforts. 23 to be multiplied in the first equation, 32 to be multiplied in the second equation, right? Feels like this is a challenge. But can you think of something? The idea is if you observe something, you might think of something. So my question changes to, do you observe something? I guess yes. The coefficients are interchanging, isn't it? The coefficient x has here goes to y, and the coefficient y has here goes to x. Does that have something to do with the question? Absolutely yes. When you see such kind of scenario being made up, the coefficients getting crisscrossed, interchanged, add both the equations and see what magic happens. So if I add both the equations, what happens is 32 plus 23 gives me a 55x. 23 plus 32 gives me a 55y. 41 plus 14 gives me a 55. And now do you see I have a 55 common, I have a x plus y, and I have a 55 here. 55, 1 ja 55, and I have a beautiful equation with me, that's x plus y is equals to. Ready? Simplified equation? Just by simply adding. Now the point is, fine, you have one equation, but about the another equation. I guess no problem in that. You can easily make this one of this, right? Or there is another plan. Second, you subtract these equations, right? Second, you subtract this equation. Now, let's have a look. So, see, we have 32x plus 23y equals to 41, right? Next, you have 23x plus 32y is equals to 14. What if I subtract them? 32 minus 23, that's a 9x. 23 minus 32, that's a minus 9y. 41 minus 14, that's a 27. 9 comes common, or now you can straight away cancel. 9 1 ja 9, 9 1 ja 9, 9 3 ja 27. So we divided each and every term by the 9. Fine, no problem. Be smart now, be a little faster. This is your second equation, x minus y equals to 3. So the first step, add up them. Second step, subtract them, and you get a two simple equations. You can easily solve them. Already simplified for you. You can straight away eliminate by adding. As soon you add, what happens? This gets cancelled. X and X you have 2x, 3 and 1 you have a 4. X comes out to be 2. Fantastic. Isn't it beautiful? Now stop and watch till here. Added, simplified, subtracted, another simplified. Y with the opposite coefficients, but same, added. Y gets eliminated, 2x4, x2. Put x here and get y, and now do it a little faster. So in my mind, I have x as 2 plus something equals to 1. 2 goes over there, y becomes 1 minus 2, that is minus 1. So now slowly and slowly you are picking up the pace. We are done. Now if you got it, I would say pause the video, and this is the homework which I want you to do on your own, and let me know in the comments the answer, of course, right? So we'll go ahead, similar pattern. I'll also get to know that you're learning from these videos, will give me more enthusiasm to create much more of that content and help you out, right? So let's go. Now, what about this one? Another form of linear equation, right? So just trying to show you how the variety can be created. What generally happens, sometimes people mess it up. What will be your criteria of solving these things? How would you solve these equations, this pair of equations? How are you planning to solve it? Now, sometimes we just totally make a mess of it. We take the LCM. No, that's not required. Remember the class 8th and the 9th, the foundation you built in your high school. Remember that. Go back. Right? What we have is, we have 1 by x, 1 by y written both the sides. What if I treat 1 by x as a variable, let us say u, and 1 by y a variable, let us say v? What happens then? Then this guy 12 by x can be written something like 12 into 1 by x. Isn't it same thing? 12 by x. This can be written as 6 into 1 by y. Same thing. 6 into y is equals to 1. 1 by x you have assumed as u. So you have a 12u. 1 by y you have assumed as a v. Minus 6v equals to 1. You have a linear equation with two variables. And now with time, you can directly jump from here to here without writing this. See what happens. 12, 1 by x becomes u, minus as it is 6, 1 by y becomes v. Isn't it beautiful? So if you got it, pause and then try to write down this equation directly in the form of u and v without writing this step. See, I'll help. So we have done. Try. 36 as it is. 1 by x becomes u minus as it is, 24 as it is, and 1 by y becomes v. We have the two equations sorted. Now it's the time for the elimination. Let's make 12 the coefficient of u as 36 the coefficient of u here. Simple. Let's multiply it by what number thing? What multiplied to 12 makes it 36? 12, 3 is 36. So 12 3 is 36u minus 6 3 is minus 18v is equals to 3 1 is 3. Check. Eliminate the u, get the y, and tell me, my dear friend, are you done? So we have the same sign, subtract. 36 minus 36 gone, minus 24 minus minus is plus, so minus 6v. 1 minus 3 is minus 2, minus gets cancelled, v comes out to be 2 by 6, or maybe 1 by 3. Fantastic. So we have v, time to calculate u, right? Or maybe by v we can easily calculate y. Put it there. So you have the value of v as 1 by 3. We know v was 1 by y. In place of v, I'm keeping 1 by 3. getting rid of the v because now I know it. So I know v was 1 by 3, so I simply replaced v by 1 by 3. What did I get? 3 goes over here equals to y goes over here. So 3 is equals to y. Congratulations, you have the y. Sorted. Let's keep it here. Y is equals to 3. One part is done. Time to calculate the x. Very simple. Put in y in any of the equation. I'm putting it here. And let's check what happens. Let's put in a line here. So 36 by x minus 24 by y, that is 24 by 3 equals to 1. 3 8 ja. Minus 8 goes there, becomes plus 8. So 1 plus 8 is a 9. And here you have 36 by x. 9 1 ja, 9 4 ja. Right? X goes over there, gets multiplied. So x is equals to, we have 4 on the left hand side. So y3 and x4, we are done. You must be thinking right now that it's too much of time consuming. But don't worry guys, generally we avoid these kind of steps. Once we get the y, we put in here and do it in our mind. That time will also come. But today, since it is the first class and we are starting to build the foundation of 2026, it's okay to be slow, but concrete, right? Pause, try, rewind, watch again, get comfortable, and then only move ahead, right? Then only move ahead. Don't just watch it as a movie. You have to be very careful with one page while moving to the next one. Okay, very careful. Okay, for me, this video might be an hour or maybe a little longer, but for you, it should at least be 2 hours. The content here is for 2 hours. Fine. So let's go. Okay, guys. So this is a question for you. You will do this in homework, very similar to the last one. Why I'm giving you a lot of homework? I want to check that whatever I'm teaching you, are you able to do it on your own? So this one homework, very similar to the previous one. Hint, you will put 1 by u as x and 1 by v as y. And I wish to know the answer in the homework to just know that are you able to do it? And I'll give a thumbs up so that you get to know the comment on which I'm giving the thumbs up is the right answer. Okay, let's go. Now, let's start observing a little more than the solving of the equations. We have solved it. We know we have two equations, two variables, we can easily solve it. Fine, fantastic. But what if there are some extra things which cat wants us to see? Let's observe more. Now guys, if I give you an equation AB equals to 11, find A and B, you cannot, right? There are too many things, right? A can be any damn thing. Let us say if I put A as 1, then this becomes 1 into B is equals to 11, right? AB 11. And then B comes out to be 11. One solution, A1, B11. Too many things. If I put A equals to 2, then AB equals to 11 simply means 2 into B is equals to 11. And in that case, B equals to 11 by 2, right? And you can keep doing. So many of them, right? But cat will play a little smartly. Cat will suddenly give you another line, A and B are positive integers. And now the things like this 11 by 2, they do not stand a possibility. So once we have a statement like this, we should start thinking, all right, there is some extra information that they are positive integers. Something has to be done. Otherwise, why would they just add a line? Not just to make the question look big. This is not a RC. Now the idea is, guys, if A and B are positive integers, have a look at this equation. This is nothing but we have two numbers which are positive integers and they are being multiplied to get 11. What are the two numbers that get multiplied and yield 11? How can two numbers be multiplied and give us 11? There stands very limited possibility, and that is, see, this is the prime number. This can only be formed either by 1 into 11 or by 11 into 1, yes or no? There is no other possibility. You cannot break 11 further. So that means if I say AB is equals to 11, I have only two possibilities. It becomes 1 and 11, or it becomes 11 and 1. So far, I'm not able to solve again. I cannot comment on A and B, but yes, I'm down to two possibilities. Now, if you give me any extra information, let us say A greater than B, I'll get to know that, okay, this guy is the answer. Or you give me B greater than A, I'll tell you that this guy is the answer. Yes or no? Now, we have started to build another way of approaching a question, specifically when the integers come into picture. Now, it was not just about solving the equation, we have two variables. No elimination, no substitution, just another way of approaching equations which needs to be developed. The call of the modern art, or the call of the modern cat, or I'll say the modern art of cat, it's visualization, observation, optimization, where majority lacks. We need to develop it slowly and slowly. Let's have a look at more. Try this question. Similar trap. Pause. Must try before you go ahead. AB is 127. Find A plus B given that A and B are positive integers. Have a look. Again, think, is A, B equals to 127 have much of the opportunities there? So we know that they are positive integers. Some role definitely played. 127. Let's think of 127. Is it a prime? Oh dear Lord, yes, it's a prime. 127 cannot be broken up, right? It's definitely a prime. You'll think of few numbers, you'll not be able to get it. See, sum of the digits is 10, cannot be divisible by 3. It's an odd number, cannot be divisible by 2. It does not have a 5 or 0 at the end, cannot be divisible by 5. Tried manually by 7, 7 1 is 7, 57, not be divisible by 7. 11, 11 is 121, then 132, not divisible by 11. Oh, we have done the divisibility test of all the primes from 2 to 11. And the square root of this number is very close to 121. Square root is 11. So if the prime numbers less than the square root of this number cannot divide it, it is 100% a prime. Within the equation, I have told you one beautiful concept again. Otherwise, you simply realize it is a prime. And if you cannot, you have to do it that way. Approximate square root of this, 11 point something. If the prime numbers less than 11 point something cannot divide it, nobody can divide it. And the prime numbers less than 11 is 11.7532. I tried all those 5. They cannot divide it. This is a prime. Now, if this is a prime, there are just two possibilities. Product of two numbers giving me a 127, that means a 1 and a 127, or a 127 or a 1. No other possibilities, right? So AB equals to 127. You again stand with two possibilities that, if we go ahead with A and B, you have 1 and 127. They product to give you 127, or 127 and 1, they product to give you 127. Now the point is, the question says A plus B. So what is A plus B? I have found out that, okay, these two numbers, they stand the chance because they product to 127. But question asks for this. If I add this, I get 128. Even if I add this, I get 128. So it doesn't matter whether A is 127 or B. I don't care. I'm not here to tell you what is A, what is B. I am here to tell you the sum of the two numbers that product to 127, and the sum of two numbers is 128. Whether it be this case or this case, I don't know. The answer is C, not D. Yes or no? So that's how things can be played. Yes, there were two options that can product to 127, but the sum of both the options is 128. And what you are interested in is the sum. Yep. So the answer C, my dear friends. Right? Let's move ahead. and talk about another such question. Have a look. A to the power b is 16. Find the minimum value. Now started to play with the optimization, the aptitude stuff, such that a and b are integers. Again, we have that trap line. One equation and two variables. Yes and no. Think. Now let's just imagine we know that a to the power b is 16. Can you think of some equation or some exponential form which can give us 16? Think. I need the integers. So things started to come to my mind, starting from 16 to the power 1 is 16. Fantastic. Then what do I have? I have, it cannot be a power of 8. It can be a power of 4 then. 4 to the power 2 is 16. Fantastic. So then 2 to the power 4 is 16. Fantastic. Fine. You're looking for the minimum value of a plus b. So far, the value of sum of a plus b is sum of base and exponent. Sum of base and exponent here is 17. Base and exponent sum to 4 plus 2 6. 2 plus 4 is 6. Seems like the answer is 6a, but that's not the right answer. Nowhere it is mentioned that they are positive integers. This time it is mentioned that they are just integer. What if they turn out to be negative? Can a negative power give us 16? Let's think. We have to think on this line only. Minus 16 to the power 1? No, that's a minus 16. We need a 16. Out of picture. Minus 4 to the power 2? Is it 16? Yes. Minus 4 into minus 4 is 16. Minus 2 to the power 4? Yes. Even power again will make positive sign. So these two are another two options which are allowed. Now what is the sum of base and the power? Minus 4 plus 2 is minus 2. Minus 2 plus 4 is a 2. So these are the possible values which we can create. You are asking me the minimum. The minimum among this 1766 minus 2 is minus 2. So C wins. Got it? How many of you missed these two cases of negatives? Do tell me in the comments. At least I'll get to know that, okay, you're learning from the traps, right? Don't hesitate. It will help me to create more such traps so that you get more comfortable. So the more you communicate with me, the better or the more personalized content I can create for you guys, right? You tell me you're uncomfortable with this, I'll create more traps with this. You tell me that, okay, you fell for this, I'll create more questions like that. And that's how we rectify your weaknesses, right? And now it is the time when we actually see how all these observations are making their way to CAT with a very recent example, CAT 2025 slot 2. Looking at this, some 2025 students might go into a flashback, right? I hope that flashback is good though. Okay, try it out. Right, try it out. Maybe you are there till halfway, maybe you are able to solve just 20% of it, but you should try it out, right? I'll get to know that how you are doing, how you're dealing with it, up to where you are able to solve. You will get to know that what is the point where you get stuck. Do solve it, do try it. All right, so my turn, right? Too much. This question has not ideal for the first class, but definitely ideal for the first class if we are willing to just see what CAT checks us on. What are the areas which we need to cover? Okay, so for that purpose, I bought in here. Have a look. M and N are integers. Fantastic. If M and N are integers, what I know is these two brackets you are talking about are definitely integers, right? Integer plus integer is integer, integer plus integer is integer. This multiplied by this is basically the product of two integers. So what I'm looking is that if this products to 27, I'm looking for two numbers that product to 27. Think of those two numbers. Think on that line. We'll come to this later, maximum possible, whatever. Think on that line. Can you think of two integers that gives you 27? We did it in the last question. That time it was a prime, like 11, 1 into 11, 11 into 1. Now we have multiple cases. So cat played with us. Cat said, okay, I'll give you many cases. Go ahead and try. Now we thought, okay, sir, we have 1 into 27. That will give us 27. We have 3 into 9 gives us 27. We have 9 into 3 gives us 27. We have 27 into 1 gives us 27. And then you say, sir, this is a integer, not a case of positive integer. We did it in the last question. So we also have the negatives. Minus 1 into minus 27, minus 3 into minus 9, minus 9 into minus 3, minus 27. 8 cases. Now there is one way that we equate this guy to this. M plus 2n is 1. 2m plus n is 27. What we'll have? One equation, two equations. Two equations with two variables, right? Let us say if we just thought of that way or thought on that line, m plus 2n is 1. 2m plus n is 27. That's two equations, two variable. We have mastered that. We'll go ahead and find out m and n. But in that case, we'll have 4 such equations to solve here. And then 4 such equations to solve with the negative terms, minus 1 into minus 27, minus 3 into minus 9. Will I solve 8 equations? Or does even cat want me to do the 8 equation solving within 2 minutes or 3 minutes? Guess not. There is something missing here, which we need to identify. So I said, okay, let's go back. We are not going to solve all the 8 equations. Let's think a little beyond. And then I observed that, okay, fine, I have these 4 possibilities and also for the negative. What if I see that here the coefficients are interchanging? So if I add them, I'll get some beautiful thing that we have seen. So if I add these two, what do I get? 2m plus m, 3m, and n plus 2n, 3n, isn't it? So that means the two numbers which product to 27, their sum, the two numbers which product to 27, their sum is coming out to be 3m plus n. 2m m 3m, 2n plus n 3n. Just watch till here, be very comfortable. So what did we observe? That somehow the two numbers or integers that product to 27, their sum is something unique. It is 3 into m plus n. Or that means 3 into something, right? That means the sum must be a factor of 3 or a multiple of 3 rather, sorry. That means the sum of the two integers that product to 27 must be of the form of 3 into something. Let's check it out. What is the sum here? 1 and 27. 1 and 27 sum up to 28. Can the sum of 1 and 27 be written in the form of 3 into something? No, 3 into something is never 28. It's gonna be a fraction. Sum of 3 and 9 is 12. 12 can be written as 3 into something. So this is a possibility. This is not. Then again, 9 and 3, yes, a possibility. This is not. 27 plus 1 again 28. Here you get a sum as 12, 3 into something. Here you get a sum 3 into something, 12. This is definitely not. So that means we can get rid of the first and the last one because their sum is 28. Now, guys, you are at a 95 percentile thinking. Your range is somewhere around 95 to 98. If you can just understand what we did. So I want you to go back and again see if you did not. Right. So now what we have done is we have identified the numbers that can product to 27, right? And then we have identified that, okay, great. The two numbers that product to 27, their sum should also be a multiple of 3. That means we just stand with these two now. Now we can solve one equation. See, m plus 2n is 3. I'm going to solve that. M plus 2n is equals to 3 and 2m plus n is equals to 9, right? So what I did, I knew that, okay, 3 and 9 would work. Their product is 27. One is 3, another is 9. Let's go ahead and solve it. And the best way to do it, let's eliminate n. Let's multiply this equation by 2. Fine. So I multiplied this by 2. This became 4m plus 2n equals to 18. This already I have m plus 2n as 3. Now, if I subtract, gets cancelled. M minus 4m is minus 3m. 3 minus 18 is minus 15. M turns out to be 5. Fine. So this equation gives me m as 5. Now let's put m 5 in this equation. I have 5 plus 2n is 3. This goes over there. 2n becomes minus 2 and n becomes minus 1. Fantastic. So I have m as 5 and n as minus 1. This you are a master. 2 equations, 2 variables. But now the point is, still I'll have to solve the 4, 3 and 9, then 9 and 3, and then of course the negatives are allowed. So that means I also have minus 9 and minus 3 and minus 3 and minus 9. That is also a possibility, right? Absolutely, yes. That is also a possibility. So should I solve the 4 equations? What better you have done eliminating the 4 cases? There were 8, you eliminated 4, still I have to solve 4? No, I just had to solve this one. Now let's take your observation to a 99 percentiler thinking. Right, so what I'm doing this is just to make you realize up to what level we have to go. So today if you are not able to make it, no problem. This is just to make you realize at what level we have to go. And if you can understand even a pinch of it, let me know in the comments. Beautiful, then slowly and slowly we'll develop and reach this level. Now guys, think what happens is, what changed? Do you see this is very symmetric? Here m becomes 2m, 2n becomes n. The coefficient of m goes to m, coefficient of n goes to m. And then this also symmetrically changed. 3 came to 9, 9 came to 3. Isn't it? We have just replaced m with n. Think, if I just replace this equation in such a manner that m becomes n, the first thing becomes n plus 2m. This becomes 2n plus m. What I've done is just simply replaced n with m. Have I reached again to this particular equation? N plus 2m 9 there, and 2n plus m 3 here. So I get the same thing. So what we are doing is doing nothing but interchanging the coefficients and the LHS. So what we have done is we have interchanged the RHS part, and that's it, and nothing else. So the nothing impact would be seen here. The only thing would be seen is, now instead of M5 we will get N5, and instead of n minus 1 we get m minus 1. So you don't have to solve. In case you wish to view it more, visualize it more, just put it equal to this today, put it equal to this today and solve. You will get automatically this. Although nothing happened, now m became n and n became m. That's it. Beautiful trap created. So you just solved one, you got the two. So what about this side now? Nothing. Earlier m plus 2n was 3, now it is minus 3. 2m plus n was 9, now it is minus 9. So nothing will change, only the signs will change. Earlier you had m5, now it is minus 5. n minus 1, now it is 1. n5, now you have n as minus 5. m minus 1, now you have m as 1. So I have solved all the 4 equations just by solving 1. Let me just write it this also in the order of m and n, so that we are not confused later on, or we don't make a silly mistake. So m becomes what n was, n becomes what m was. Pause and take a moment to grasp it. Too many tricks we have learned. What if we have 2 equations and the LHS changes? No change happens, just the interchange, right? But they also should be symmetric, right? LHS symmetric, RHS interchange. LHS very symmetric, RHS interchange. These guys changed. What happens if the RHS changes the sign? Both the RHS changes the sign, the variables changes the sign as well. That's it. nothing else matter. Guys, you have done it, you have cracked it. You have already reached the level of 99 percentile thinking in quant if you could understand these things. But yes, this will require a lot of practice, which I'm ready to do with you guys, right? Which I'm ready to make you do, ready to make or create such more questions. But the idea is you should let me know that you enjoy this stuff. Otherwise, I'll have to decrease the level a little bit, maybe initially, right? But that's a beautiful trap. Now the question says then the maximum value possible for 2m minus 3n, you can put in and check. And that also have a very smart thing. You are looking for a maximum value. So 2 into something minus 3 into something. How would you make it maximum? Maximum means maximum positive, isn't it? So I want this entire thing to be positive. So what I want is to put a positive over here so that this becomes a huge positive. And what I want is to put a negative here. Why? Otherwise, this is getting subtracted. But if I put in a negative, so minus minus becomes plus. So positive plus positive it will happen. So I'm thinking of m as a positive and n as a negative. M positive and negative, we have this and this. I would advise you put in all four. Then only you will realize that these two will give you a better answers, not these two. M negative, you're making the positive also negative, right? Keeping n positive, you're making this as negative itself. So negative and negative, you'll get a lot negative number. That I would do for minimum. I'm looking for maximum. So this I need a positive. This also I need a positive. This is a positive by simply giving it a positive. How to make this guy positive? I give it a minus. Minus minus plus. So let's put in this 2 into 5 and minus 1. See what happens. 2 5 are 10, a positive. Minus minus plus. See the smartness. 10 plus 3, 13. So if I put this guys, I'll get 13. What if I put this guys? 2 into m minus 3 into n, that is minus 5. m1 and minus 5. 2 plus 15, that's a 17. And the maximum value turns out to be 17. So I've cut one such question deliberately. If you see, the entire time has gone into explaining. Otherwise, what we solved was nothing but just one system of linear equation. One system of linear equation, rest all was logic and aptitude. That's CAT 2025, guys. One of the brutal and the tough question, on the best question on the linear equation I've seen in the past 5 years. But I did show you here in the class because I wanted you to see where the modern CAT is doing. I cannot hide the reality from you. We should know the reality before we start so that there is no gaps later. But yes, should we be able to do this within one day? No. Within 1 week? No. Within 1 month? No. This comes at the later part of your preparation, maybe around 4 or 5 months. Why this is important for the first class? So that we know where we have to go. So we have to be fast in that. There will be elementary steps in a good question. ऐसा नहीं है कि, right? So this is not like that these things won't be tested. These things would be tested, but as a small or elementary part of a good question, right? Okay, let's go. Let's go. A to the power 6 equals to b square plus 127. The question asks us find a plus b given that a and b are positive integers. A little property would be used over here. I hope you know that. In case you don't, I'll write it down for you. A square minus b square is equals to a minus b and a plus b. Now guys, again, before you go ahead and try, question number 1, 2 and 3 were supposed to be the one which you should have done in this class and the homework part, right? 4th and 5th, they were never to be done in the first class or in this particular class. They were just there to showcase you up to what level we have to go and what other approaches we need to develop. I don't want to misguide you, right? Or keep you in the shadows that, okay, CAT is simple. There are some things which we know. There are some things which are a little trickier, which eventually we'll cover up. There is no point of getting demotivated or being afraid of, right? We go ahead, we see a difficult thing, we don't run back. We go, we see there is a tough thing, we conquer it. And I will make you conquer that, right? You just have to stay calm, watch, and be patient. There are certain things which you already know. And there are just these little things we have to overcome in the coming time. And I am giving you a promise that you keep patience. You keep watching slowly, learn, observe. Now, have a look at this question. Seems again challenging. One equation, two variables. Seems impossible, cannot be determined. But no, wait. There is some angle again over here, and that is this particular thing. Do you see a and b are positive integers? Something will definitely be played again. What do we have? We have a to the power 6. Let's b square come on the left hand side. We have a to the power 6 minus b square as 127. 127 we know is 1 into 127. We have seen that, learnt that, conquered it, no other options. Here, can I write down this as a cube whole square minus b square? Now this is my a square, this is my b square, that's a minus b, a plus b, 1 into 127. Here you have two integers. Here you have two integers. Two integers product, that means one of them has to be 1 and one of them has to be 127. And then now I leave it onto your aptitude, which one is 1, which one is 127. Think. We have a and b as positive integers. This is sum of two positive integers. This is difference of two positive integers. This is sum. This is difference. I know the sum will always be greater than difference because they are positive. Think of any number. Let us say 2 and 7. Their sum is 9 and their difference is 5. Of course, sum greater than the difference. So this guy has to be the larger one. So this will choose 127. This has to be the smaller one. Choose 1. And suddenly what do I have? A cube plus b as 127. And a cube minus b as 1. Isn't it beautiful? Suddenly from the one equation, I have the two equations now, and now I know how to solve it. Isn't it simple? Elimination method, already the equations are set. If I add them up, I get 2a cube equals to 128. A cube as 64 and a eventually 4. 4 cube is 64. Yeah. Put a back to any equation. Let us see here. 4 cube is again 64 minus b is a 1. B becomes 64 minus 1, that's 63. So what's a plus b, guys? 63 plus 4, and that's 67. So a is the answer. Now what you will promise me is you'll solve the questions, the homework part, answer it in the comments. Second, you will not get afraid from the question 4 and 5. They were just there to observe where we have to go, and we will reach that. We'll make a promise to each other. We'll keep going till we reach that level, and we will score good percentile. That of course you can promise, but you can promise me that you will put hard work for that, because I'm ready to do that. What I need is your support in the hard work, and will not fear anything in the way. We'll see. Yes, there will be difficult things on our way. We'll conquer it. At least we'll fight. At least by the end of the November, we don't look back and see, oh, we did not even give a fight, right? So that's about the CAT. It was a glimpse of the CAT. There were a few questions which we touched. There were a few basics which we touched. And by the end, we also did see that what is the level we also will be looking forward to reach if we are targeting the 99 to 100 percentile mark in quant, which I suppose you are looking for, right? But yes, nothing to be fear for, right? 1, 2, 3 done. Homeworks you're done. You are spot on. You are my champ. Take care. See you in the next class.